As you may not remember from when we talked about waves before, the velocity of a given wave is equal to its wavelength, lambda, times frequency. Okay. So in the case of light, that velocity is c, the speed of light, and that's equal to lambda times frequency. So since that speed is constant, there's an inverse relationship between the wavelength and the frequency of the light. Wavelengths are typically on the order of 10 to the minus ninth, so nanometers are often used, although some radio and microwaves have wavelengths in the meter range. But for the things that, for most waves, the wavelengths will be in the nanometer range. There are 7 different regions of the electromagnetic spectrum that have been named and studied and whatnot. And those are radio waves, are the longest and lowest frequency. Microwaves are next. They're a little bit shorter wavelength, a little bit higher frequency, but still fairly close to that end. There's infrared, visible light, which is what defined by our vision, what we as human beings are able to see. Ultraviolet, X-rays, and gamma rays. And these all travel at the speed of light, and they'll have that inverse wavelength frequency ratio. Gamma rays are the highest frequency, lowest wavelength, and radio waves are the lowest frequency, highest wavelength. I'm not going to just spew out a bunch of information for you. On page 882 to 884, the book gives descriptions of them. You can read those, and that'll be just as effective as me telling you what the various properties are. But I want you to know the wavelength and frequency ranges for each band on the electromagnetic spectrum, and also just know, a couple of uses that, ways different things are used. Like you may already know that X-rays, are used for medical imaging and whatnot. They give you pictures of bones, just things like that. Different. So memorize the wavelength and frequency ranges, and then know a couple uses of them. But you can just read those pages in the book, and like I said, that'll be just as effective as me telling you what's going on. One thing to point out is that the band of visible light, what we can see, is a pretty small part of the electromagnetic spectrum, and it's defined in terms of eyesight. And the book does mention, and I think it's worth noting, that the wavelengths of light that come through our atmosphere, or not light, the wavelengths of electromagnetic radiation, electromagnetic waves that come through our atmosphere, are in the same, the dominant wavelengths that come through the atmosphere are in the same region as the vision of humans and animals. And I think that's worth noting. The book mentions it as an example of adaptation, though I would tend to say that that's an example of God designing us for a particular environment. So I guess it comes down to what framework you're working from. But regardless of what you believe, it is worth noting that the vision of the various animals and people on Earth does correspond to the wavelengths that pass through the atmosphere and reach the surface of the Earth. One more thing to just note quickly is that we see objects because light is reflecting off them. Okay, that's why when it's dark, when there is no source of light, we can't see things because there's no light to reflect off and go into our eye. And likewise, the color of an object, if an object is blue, that's because it reflects, on average, it reflects a blue wavelength or frequency of light. So just keep those things in mind. I think they pertain to a couple of the the questions that you're going to get in the book.